So continuing to part C. Oh, that's going to be confusing. So the electricity went out and messed up the first part of the recording, even though it's still really there. All right, so let me do back up for just a second, because I want this on the video. All right, our function is defined to equal that definite integral. Definite integrals are areas. Definite integrals accumulate things. They accumulate areas. So our function f of t, whose graph is here, is a constant function. It equals 3. So if we want to find, for instance, the integral from 2 to 3, it'd be the area of that rectangle right there. It'd be 3. Okay? So we did that for -2. We did it for -1. On both of those, I wanted to switch the limits of integration, which you can do as long as you put a negative sign in front of your integral. Now we're caught up. Now, next one, 0. Well, if you have the integral from 0 to 0, and all I'm doing is taking the x-coordinate they give me, and I'm replacing the x-coordinate in my function with it. So if you've got the integral from 0 to 0, from A to A, there's not an area, is there? There's not a two-dimensional region. It's just a segment. Segments don't have area. So that's 0. And then we can pick up the pace a little bit. Next, they want x to equal 1. So that's the integral from 0 to 1, which, if you look up here, from 0 to 1 would be that area, which is 3. And then from 0 to 2, to find out what happens when x equals 2, so all that does is put more space there. So now that integral is 6, because that area is 6. Integral from 0 to 3, add 3 more to it, it's 9. From 0 to 4, add 3 more to it, now it's 12. So we can fill in the table, I think. Can we fill in the table? Okay. Now they ask us some questions. All right? They say, on what interval is f positive? Little f positive. Well, little f is a constant function, isn't it? So when is it positive? Always. So I wrote this. F is positive on the interval from -infinity to infinity. Then they said, on what interval, if any, is f negative? It's not. So I wrote f is never negative. Then they ask, on what interval is capital F of x increasing? Well, so we look. Look at your numbers. -6, -3, 0, 3, 6, 9, 12. It's increasing there. Now, generalize. Since little f is always positive, hey, could we think of little f as being its derivative? I think we could. If the derivative is positive, is the function always increasing? Sure is. So capital F is increasing forever from -infinity to infinity. On what interval, if any, is f of x decreasing? Never. Since its derivative is always positive. And by the way, have they told us that little f is the derivative of capital F? No. But isn't it? Yes. So capital F never decreases. Then they want us to determine an algebraic rule for little f. Well, you know, we know it's 3. If they hadn't put a grid there, we wouldn't have been able to get numbers to fill in our chart. But if they hadn't have put a grid, if we didn't know that was a 3, if that was just some random number, wouldn't little f still be a constant function? So little f of t is going to equal some constant. In this case, we know what it is. It's 3. Okay? So our algebraic rule our algebraic function for little f is little f of t equals 3. And then they want us to determine an algebraic rule for capital F. Well, okay, that means work out the integral. All right, capital F of x is defined to be the integral from 0 to x of f of t dt. Now that we know f of t is 3, we've known it all along, but now that we're calling f of t 3, capital F of x equals the integral from 0 to x of 3 dt. Now, dt. So when we integrate that, we got to get t, not x, right? So the integral of 3 isn't 3x, it's 3t. So the antiderivative of 3 is 3t, but look, we evaluate it from 0 to x. 3 times x minus 3 times 0. So capital F of x equals 3x. And that is an example of the second fundamental theorem of calculus. It is not because it was a definite integral. So we haven't found every antiderivative of 3. What we have proven is that 3 is the derivative of 3x. Okay? Y'all with me? Okay. I want you to do the rest of the worksheet.